Hello, and welcome to SUSECON Digital 2022, A Clash of Titans, embracing free Libra open source software in the automotive industry. Our agenda for this presentation is as follows. Number 1, why does the automotive industry want to use FLOSS? Number 2, what stops the automotive industry from using FLOSS? And number 3, what can be done to help the automotive industry use FLOSS? Before we go any further though, we'd like to introduce ourselves. My name is Michael William Knop, and I'm the Requirements Engineer for SUSE's Automotive Linux Team.
My name is Alexandre Vicenzi, and I'm a distribution engineer in the automotive team.
So why a clash of titans? Well, the automotive industry is certainly a titan. It's a $4 trillion global industry. It employs millions of people around the world. Entire nations rise and fall with its fortunes. FLOSS is also a titan. It has become the foundation of modern digital existence. But it's a titan without a head, so to speak. The clash is, why can't they get along? And now I'm going to hand it over to Alex.
Okay. Free and lib open source software is so prevalent that it's difficult to imagine life without it. To give you some perspective on how massive it is, according to a research published by the European Commission, open source software brought a positive impact on the European economy of 65 to 95 billion in 2018. To put these numbers into context, uh, the economic value of open source software in the EU is equivalent to both air and water transport combined. This study also shows that open source is a key element for digital transformation in the European Union. The state of Octoverse shows that GitHub has over 73 million developers on its platform, over 16 million users joined last year. In 2021, GitHub also had over 61 million new repositories created and over 170 million pull requests merged. The Linux kernel is the largest open source project ever created, and according to Phoenix, the project has more than 27.8 million lines of code. The 5.17 kernel release had over 13,000 chainsets contributed by 1,900 developers. But where all these contributors come from, uh, the IT sector is the main driver of open source and corresponds to more than half of these contributions. Companies like Google, Microsoft, Facebook, Red Hat, and SUSE, just to name a few, are the main and most active contributors. The European Commission research also showed increasing contribution from other industries in the EU, most notably like manufacturing, retail, banking, and in insurance. These contributions suggest that companies are increasing support and attention to open source software. Finally, developers employed by business are the major contributors of open source. The idea of a one person project and the do it yourself reputation, we're left behind. But why companies and entire industries are embracing open source software? Well, the main reasons are fast technological development and digital transformations. Open source software has a global community that helps mature technologies. These technologies are often solving real world problems. Software developed in the open is less vulnerable to attacks. The main reason is that it's easy to access, test, and audit such software. When problems are found, they are also quickly fixed by the community. Uh, Using open source software that is already existent, tried, and tested is the fastest way to get products built and ship it to market. For example, there is no need to rewrite network stacks or compilers. Open source also allows vendor neutrality. You're not locked into a technical stack, product, or licensing agreement. Some of the world's largest and most regulated industries are working together. Businesses such as banking, telecommunications, energy, and public health became dependent on open source software. These industries are under constant pressure to innovate and often choose to rely on software to redefine their process and assets. The Linux Foundation became a catalyst for initiatives in major industries. For example, the banking industry is trying to solve is working together to solve common market challenges under the FinTech Open Source Foundation. The telecommunication industry is trying to solve connectivity problems and is contributing under LF networking. The energy industry is moving towards a software defined infrastructure and is contributing under the LF energy. Public health had to address the COVID pandemic recently, and collaboration started under the LF public health. Uh, the automotive industry is moving towards open source, but in baby steps and with caution. The automotive industry is also high regulated through standards, norms, and contractual obligations. This increases its caution to disruptive changes, such as open source. A study done by Kuglermark published this year revealed that the business the business case around open source is mostly to reduce initial investments in development and to save time to market. Open source is currently heavily used during development, but inside a car is mostly found in connective systems such as the infotainment. At least one embedded product at each company interviewed in this study includes open source software in its stack. When we talk about open source, the warranty and liability part of it is often slowing down the adoption of open source. When it comes to safety, broadly speaking, there is very limited or almost no use of open source software. This is also true for other industries such as aviation and medical, not just automotive. Giant parts of the software stack used in the automotive are maintained in a proprietary way, but many parts should be implemented and maintained as industry standards. The complexity of modern automotive systems cannot be handled individually. All companies interviewed in this survey agreed that open source is essential to enable innovation and future technologies. And now I hand over to Michael.
Thank you, Alex. So what is stopping the automotive industry from using FLOSS? The canyon between FLOSS and its use in the automotive industry has a name, Aspice. And now to a lesser extent, or actually a greater extent, it's also ISO 26262, a functional safety analysis ISO. But we're not going to talk about that ISO in this talk. We're going to focus on Aspice because Aspice is a gateway to that functional safety analysis. So what is Aspice? Aspice is a framework to judge an organization's capability to develop software for the automotive industry. It's important to know that the goal of Aspice isn't to create flawless software. The goal is to reduce risk. And that is, if you comply with Aspice while creating your software, you reduce the risk the software has bugs. Aspice is divided into two general categories. There's engineering and non-engineering processes. Software and system development and their verification make up the engineering processes, and there's also other plugins for hardware and mechanical development, but we're going to focus on software. In the non-engineering processes category, we have your basic project management things like change requests, risks, handling quality assurance, and communication between suppliers and customers. And here we see a kind of a breakdown of the process groups and the processes within them from Aspice. In the middle, you see the system engineering and software engineering process groups, and they form kind of a V. We'll talk about that in a minute. And surrounding them are the other processes. So what's the general problem? Well, generally speaking, Aspice was created when all software that went into a vehicle was custom made. Now, there are some specialized softwares like real-time operating systems and other frameworks, but these are usually created under Aspice as well. Aspice assumes that the software developer has complete control of all the code that goes into the product from day one of its life cycle. And the engineering processes within Aspice follow a V-model approach, which you see on the right-hand side there, with requirements, architecture, and tests from the system level down to the software level units. So that's the general problem. If we want to look at specific problems, we have two examples. One is the requirements. So in Aspice, requirements drive development, architecture, and testing. And this is also true in other industry standards, but requirements are the foundation of all these other activities. Open source projects typically don't start with a requirement spec with the level of detail that Aspice would expect, and it would be a Herculean effort to, after the fact, document a large open source project with requirements, such as the Linux kernel. Another specific problem is testing. Per the V-model approach, every level of requirements and architecture is tested thoroughly, and those tests have to be linked back to those artifacts. Open source projects typically don't have the number of tests or the tests with the level of detail or traceability that Aspice would typically expect. And it would be another Herculean effort to, after the fact, create all these tests for a large project like the Linux kernel. Now, Aspice is mostly applicable to software for critical driving functions like controllers for the engine, the transmission, brakes, and so forth, and also for critical information displays like the cockpit. And the cockpit would display something such as your speed, your fuel, and so forth. Aspice also applies to the advanced driver assistance functions that control those controllers. And so here we're talking about features like adaptive cruise control, lane keeping assist, blind spot detection, etc. Aspice is usually not applied to non-critical software like the infotainment unit. After all, many cars use Android for their infotainment unit, and that was most certainly not developed under Aspice. There have been a few small open source projects that have gone through the Aspice process, so we know it is possible to be done at least at a small scale. And also, again, we should note that this is a general problem in all safety-conscious industries like aviation or medical devices. So what can be done to help the automotive industry use FLOSS? Well, one possible solution is to drag open source software kicking and screaming into compliance with Aspice. In other words, we do the hard work of documenting the requirements, architecture, and design, plus write all the needed tests and link everything together. But who's going to do that? Who's going to create all that documentation and all those tests? Well, the open source community itself has shown little to no interest in the boring, thankless work of formal V-model requirements and requirements-driven tests. No company in the automotive industry wants to spend the time and money, especially if other companies benefit from it. So perhaps there could be some combination or collaboration here. And here I'm going to quote the Kugler-Mogg report from before. And they said that running an open source project under the auspices of a foundation would enable collaboration without fear of antitrust. So even Kugler-Mogg thinks that this might be possible, but it's still a long shot. Another possible solution is that the automotive industry accepts that making open source software compliant with Aspice is a non-starter. That's much less the functional safety analysis under ISO 26262. So instead, we create a new standard to address open source software. And in fact, just that's going on right now. There's a new draft ISO out there covering road vehicles, specifying how to do functional safety analysis for qualification of pre-existing software products. So this sounds great. However, no public statements have been made how this is proceeding. We really have no idea when that might be adopted or if it would be adopted. They have been clear that this isn't a shortcut around Aspice or the ISO 26262, and that's very important. That the software created with this new standard won't be less safe than previous software standards. And this is very important for the auto industry because they don't want to accept a less safe solution. But even if this ISO did come to be, there's little chance that the analyses done according to it would become public. These sort of functional safety analyses would become very valuable IP. So a third solution is compromise. Instead of fulfilling the letter of Aspice, let's say we comply with the spirit. So the non-engineering processes can be complied with to the letter. In fact, the SUSE Automotive Linux team is working on this, and we'll see that in the next slide. The definitions used in the engineering processes would have to be modified and the practices around them adapted to achieve this spiritual compliance. So for instance, in Aspice, a unit of software would need to be enlarged from what is currently a C function to something bigger. And in this way, we might solve the clash between automotive and FLOSS. However, the customers of the open source solutions, and here I'm talking mostly about the OEMs and the tier ones, they would have to accept the modifications and agree that the spirit of Aspice is intact. And this is something they would have to agree to upfront. They couldn't spring this on them later. And this might pave the way for open source software to be considered quality managed. Now, this QM label is the very lowest level of usefulness for a safety analysis. Anything that's not quality managed can't be considered in a functional safety analysis. So if we could achieve at least QM, then we could be inserted into these analyses. So what's currently going on at SUSE? Well, the SUSE's Automotive Linux team had a workshop with Kugler Mag back in March of this year. We continue to work on compliance to the non-engineering processes. There is some progress here. Much of the material already exists, but we just need to mold it into shape for Aspice. And we're having discussions on the redefinition of this software unit within Aspice and what that new definition would mean for the software engineering base practices. And this is going to continue on for some time. The important point is there are no easy wins here. And what we're really looking for is buy-in from the thought leaders within the industry. And these are called principal assessors in Aspice. However, even without Aspice compliance to our supply chain, SUSE Linux is currently running on a production road vehicle. So we've already had that win. That's our talk. Thank you very much.